This is Lab 1, Charged Tapes. The purpose of this experiment is to prepare charged pieces of clear tape and observe their interactions. From there, the goal is to determine approximately how much excess charge is on one piece of clear tape. For the models, a computational model of two charged tapes exerting an electric force on each other and experiencing a gravitational force is created, and then also a computational model of two charged tapes represented by lines of charges is created. And the physical model charge is 1.15 times 10 to the negative 8 coulombs. Gravitational force, electric charge, electric field, Newton's second law, Coulomb's law are all some of the principles, physics concepts that are explored in this lab, and some of the formulas are shown here. The system is the second piece of tape. The surroundings are tape A, the desk, and any other variables in the environment. And then for initial conditions, the tape length is 0.18 meters, the tape width is 0.02 meters, the tape mass is 0.00818 kilograms, and the distance is 0.052 meters. Here are the calculations for the electric charge in coulombs. You can see going through the formulas and then getting the ultimate electric charge, which is 1.15 times 10 to the negative 8, which reflects what is also listed here. And then here is an example of some of the code for the computational model, and then hand calculations for gravitational force, magnitude of gravitational force, and electric force. So for magnitude of gravitational force, that came out to be that number, and then similar number for magnitude of electric force came out to be 0.0017607. And then I also listed some of the assumptions about air resistance, friction, and table material. Some of the possible sources of error: the mass of the tape was calculated using a basic formula and not assessed by placing the tape on a scale. So instead of using a scale, we just measured it using the formula, and then there could have been some human error when touching or moving the tape, maybe fingerprints, things like that. And then the conditions of the room, humidity might be a factor. If a room is, or temperature wise, maybe if the room is super cold versus super hot, those can be variables as well. And then what if the electrons were positive and the protons were negative? The observations would remain the same. The opposite charges would still attract and the like charges would still repel. And the point charge model and the line charge model are different because it's the difference of whether the charge is distributed over a single point or across a line, and the line will be a better predictor or assessment of the distribution of data because it's not just concentrated in one singular location.